Okay, next up, when you read the question to the nearest tenth of a degree, so that's telling us that we need to round to the tenths place. It also is telling us that we're working in degrees. So that would be a good time to turn your calculator and set it to degree mode instead of radians. And again, we're looking for all possible degree measurements from 0 to 360. So this is just one full rotation. We're rounding, and before we get started here, our goal right now, before we do anything else, is to isolate first this cosine function. We can't really use any trig properties right now until we isolate the cosine function, which means we would have to subtract 9 from both sides and then divide both sides of the equation by 3. Doing so, that's going to leave us with cosine theta equals, so when I subtract 9 from both sides, that leaves me with a -2 on the right side of the equation. And then when I divide by 3, I end up with a -2/3. A couple things to pay attention to here, right? All sine, tangent, cosine. This is a negative ratio for cosine, which means that our angles that we're going to look for are going to actually end up in the second and third quadrant, since cosine's positive in the first and the fourth. This stage here, since we identified the quadrants our angles are located in, the only move we have right now is to isolate the angle measure theta. And then to do that now, we have to use the inverse cosine function on both sides of the equation to isolate. Oops. I'm writing sine, it's cosine. Now, as I write this, remember the inverse cosine is also restricted to angles you can work with. Those angles run from 0 to 180 degrees. The nice thing about the inverse cosine is when you take the inverse cosine, the answer you get is almost always going to be one of your angle solutions. So let's finish this. And then now I'm going to use my calculator, make sure it's in degrees, and take the inverse cosine of -2/3, which would be -2 divide 3 in your calculator. And in doing so, my calculator is producing an angle measure that appears to be in the second quadrant, which is 131.81 degrees. So this is one of my solutions, right? We need a second quadrant angle solution here. That's one of my solutions. Now, moving from here, there's two ways to approach it. I'm going to show you one way, which might seem like the longer way, but this method will be beneficial because it really depends on the trig function you're working with, the ratios, positive, negative sign, and what quadrants your angles that you're looking for must be located in. All right, so this is a second quadrant angle. We have to find an angle in the second quadrant, so this one's done. I'm going to sketch myself a diagram here, give myself a little space. All right, so let's look at the circle. I'm going to sketch a 131-degree angle here in the second quadrant. So I'm probably going to terminate right around here. This is the angle that we just identified, 131.81 degrees. And now I'm going to look at the reference angle here, right? So that reference angle can be obtained by subtracting 131 degrees from 180. I'm going to use my calculator and subtract 131.81 from 180, and this is giving me a reference angle that is 48.1896. So I'm going to write, because I'm going to, this is not an answer. I don't want to round it yet. 1896 degrees right now. All right. So back up here, I know I need a second and third quadrant angle, excuse me. So I'm going to sketch myself a fourth quadrant angle that has the same reference angle as this angle does right there. My reference angle here is again 48.189 degrees. So now I want to find the angle that measured from standard position all the way to this third quadrant angle here. And in order to do that, in this case, I know that half a rotation is 180 degrees, and this reference angle here is 48 degrees. So I can add 48 degrees to 180 degrees, and that'll give me my third quadrant angle. So 180 plus 48.1896 on my calculator. I'm going to do that. And that's going to give me 228.189.18968 degrees. We're rounding to the tens place. So here's my second quadrant angle here. And then my third quadrant angle is going to be theta is equal to 228.19. But then I'm remembering that I think it said round to the tens place, nearest tenth. So I'm going to update those angle solutions to 131.8 degrees and 228.2 degrees here. These are my two solutions within 0 to 360 degrees for this equation here.